Okay, what is a basic neuronal model of attention? Neural mechanisms of attention are probably simpler and less controversial than those of consciousness. And key features to consider the neural mechanism are the following. One is that whether they are measured under the top-down or bottom-up attention situation, and whether the attention is manipulated through spatial or temporal or feature or object attention. And then key to understand attention is that the hierarchical organization of the visual cortex and also competing neural interactions. So in terms of the visual hierarchy, I explained a couple of weeks that the receptive field size changes from V1, V2, V3 to IT. In general, the higher areas tend to have larger receptive fields. And this is a very characteristic architecture of visual system, and this introduces biasing of competition to resolve ambiguity. And so this is the schematic model that I'm gonna use to explain what happens in this situation. So here, what I'm showing in this figure on the left side is that, let's say, you see a stimulus like this way. Let's say, where you are looking at somewhere here. And then when you are fixating at this, cross, then there are potentially like 4 stimuli. And then within area B2, what's happening is that some neurons that have a receptive field corresponding to each location of the stimulus is there. And then maybe in B4, there are neurons that receives the input from each of the respective B2, but it eventually forms some kind of response to the square at that location. That's a kind of the input, forward input kind of connectivity, hypothetically. Okay, and then as stimulus, let's say I don't present anything up until time 0, and then suddenly present a stimulus, this a square like a line orientation at this time 0, and then until time 1. So that's the time course of the experiment. And then what happens in at the level of neurons, if you can record all of the 5 neurons at the same time, then what happens is that for each of the neuron that responds at each location, if that neuron prefers a particular orientation, let's say, if this is a neuron 1 and that prefers this, apply this orientation at that location, then it shows the activity that increases at the stimulus, onset. And same goes for number 2, 3, and 4. Each of them likes this orientation, this orientation, this orientation, and then that corresponds to increase of the response here, 2, 3, 4. Okay. Then that what happens in the level of the V4, and of course, because V4 integrates the response from all of them with a positive kind of weights, it goes from 0 to really huge response here, right? And that's the idea of this, hierarchical stimulus processing from V1, V2, V4, with a larger receptive field corresponding to pooling of the response from the lower visual areas. All right. Now, what happens if we present only one stimulus among 4 possible situations, or weaken the 3 other locations by lowering the contrast, something like this situation? Okay, it still looks like a kind of square, but only one of them is enhanced its salience. So that's a sort of bottom-up attention manipulation. And then in this case, what happens is that in this case, what happens is that because only this neuron in B2 responds very strongly and the others are not so much, V4 will receive a less input from all over the other 4 neurons, so it reduces activity a little bit, right? So that's the reason why we see a drop of activity at the level of V4. Okay, and then now as a next situation, we consider this situation where we present one stimulus at the bottom left that this neuron in V2 does not prefer. So other three locations, we present stimulus that is mildly exciting these three V2 neurons, but it's almost negligible. On the other hand, this unpreferred V2 stimulus is presented on this location. And then because this one, these neurons in V2, which becomes inhibited here, and also this type of the response does not contribute to V4 neurons excitation. It generates very weak activity in V4. Okay. But now we make the things a bit complicated. So here we present both, unpreferred stimulus here, and also preferred stimulus here, and they make the stimulus strength stronger. And then what happens? Then the B2, this neuron actually becomes very active. So B4 can receive a stronger input from B2. And that predicts that it's going to be really a huge response. On the other hand, these particular neurons do receive the really bad input so that it can suppress other neurons. So what happens? So these two neurons have a different level of the activity level. And then as a result, you might predict that, okay, so that result in the half of what it can do when it's presented only with this or only with this. All right, that's a prediction. Now, if there is something called attention that can select this neuron, top right, V2 neurons, and then that V2 neurons can inhibit the influence of this unwanted stimulus on the bottom left at the level of V2. So there is some kind of an interactive inhibition going on from top right neuron to bottom left neurons here. Okay, that inhibits this, neuron. Then, happily, B4 neurons are actually going to receive good input as a whole from all these, other three neurons, and also bad influence from this, one of the B2 neurons gets kind of diminished, and therefore B4 neurons response goes up from the intermediate to almost as strong as before. That's a prediction. On the other hand, if there is an attention that selects this unwanted stimulus for this particular V2 neurons, then this guy can also suppress this really good stimulus response within the level of the V2, right? Then it gets something like this situation. So this anti-preferred stimulus attended, and as a result, it suppresses the other neurons in V2, and V4 receives much weaker response, exhibits a much weaker response because the dominant input is coming from V2, which is unpreferred to excite this V4. And the very good input is now suppressed at the level of V2, or maybe at the level of V5. And as a result, this stimulus configuration gets produces much weaker responses as a whole at the level of V4. So, in summary, what I tried to show was that the schematic idea of one of the most simple and popular neural models of attention called biased competition model. And basic idea is that there is a field, the difference in the size of the receptive field. The bigger receptive field neuron contains many neurons that have a more smaller receptive fields at the lower level. And if some kind of attention biasing signals can operate at the lower level, then that effect can inhibit each other at the lower level or towards higher level, whatever it is. But as a result, higher level visual neurons can change its activity as if the perceptually or selecting one of the most important features or that this neuron likes. So it's a competition that is required, and then biasing this competition. That's the solution to this problem. And Desmond and Duncan's review is reviewing that there are lots of and also subsequent studies over the last 20, 30 years, followed up the studies to support this model more or less. And we next look at what is the exact neural evidence to support this.